On problem 34, we want to use a technique of breaking apart the fractions. So anytime you have more than one term on top with a common denominator, you can break them apart. So I put the 1 over 9t, and then I'm adding the 2t cubed over 9t. And the advantage to that is that you can then just integrate them separately. I should have had parentheses here. You can integrate those separately. So we know that, or we have to know that when we integrate 1 over a variable, that always becomes the natural log of the absolute value of that variable. And then the 1/9 is just a constant out here in front. And then this is just your power rule. Add 1 to the original power, so that becomes a t to the third. And then you divide by the new power of 3. So in order to simplify that, 2/9 divided by 3, I multiplied by the reciprocal 1/3, and that's where I'm getting the 2 over 27 times t cubed. So remember, that's one of your integral. If you have an integral of 1 over some variable t, it's always the natural log of the absolute value of that variable. And then like I said, the 1/9 is just a constant that came out in front there. Okay, so when I look at 35, again, when you have two different parts, so I've got just a plain 9 and I have a 9x minus 19, you typically want your u to be the higher power of x. So the 9x minus 19 becomes my u. When I derive my u, I just get a 9dx. So this one is a perfect example where it substitutes beautifully. So in place of 9x minus 19, I put my u. Notice it was raised to the power of 8. And then in place of the 9 times the dx, I put in my du. So this is just a simple power rule integration. Add 1 to the power, and I get a power of 9. Divide by the new power, and then resubstitute your u back into the original function. Don't forget about the c. All right, question 36. Again, you've got two different expressions you're looking at. You've got a 9x plus 2 and a 9x squared plus a 4x. So let your u be the higher power of x. So u is going to be your 9x squared plus your 4x. And then when I derive that u, I get an 18x plus 4. Now, I don't notice an 18x plus 4, but I do notice a 9x plus 2. So you ask yourself, can I turn what I have into what I need? And what I realize is that if I factor a 2 away from your 18x plus 4, it's going to leave you with this expression of 9x plus 2, which is what we need for our substitution. So then we want to get rid of the 2, so we'll divide it on both sides. So when we make our substitution in a minute, we'll be plugging in the du over 2. du over 2 is the same as saying 1/2 times du. So again, I like to pull the constant out in front, and then here's my du. So I made that substitution, and then notice that your u, what we're substituting for u, is on the bottom, and it's raised to the 4th power. So I plug it in as this 1 over u to the 4th, which I then rewrote as u to the negative 4th, just to make it easier to integrate. And then I just did the power rule. Add 1 to the new power, and I get a new power of negative 3 divided by the new power. So when I take 1/2 divided by negative 3, remember that's the same as multiplying by the reciprocal to get it off the bottom. And when you multiply 1/2 times the 1 over negative 3, you're left with a negative 1/6. Resubstitute back in. And again, I'm just showing you here, I don't care whether you leave your final answer with the negative power like that, or you move it back to the bottom of the fraction. I will take it either way in that particular case. Question 37, I see two groups of terms. I see a 4x cubed and a 6x to the 4th. Let your u have the higher power of x. So your u will be the 6x to the 4th. When you derive it, you get a 24x cubed. I don't have a 24 over here. I only have a 4. So I asked myself, how can I turn that 24 into a 4? And what I realize is that if I factor a 6 out and then divide both sides by 6, then my du over 6 is what will come in and take the place for the 4x cubed that I actually have. So again, du over 6 is like saying you have 1 over 6 times du. So I pulled the 1 over 6 to the front. And then notice you have an e in here raised to the power of u. So it's the integral of e to the u du. And the integral of e to the u is just e to the u. So that was just a quick 1/6 times e to the u plus your constant. Resubstitute your u back into your final answer. And so we get a 1/6 e to the 6x to the 4th plus our c. Okay. On 38, what I notice is that you have just a constant and then you have a term that has an x. So we're going to let our u be the term that has your x here. And then when we take the derivative of that, we get just a 9 dx. So once again, I don't see a 9 sitting over here. I see a -5. So I've got to manipulate it. So I get rid of the 9 by dividing it. And then I bring in the -5 by multiplying it. So when you get ready to make your substitution, you're going to have a -5 over 9 times your du that's going into the problem. So here's my -5 over 9. Put it out in front. Here's my du. And then notice that in the original problem, your u is in the bottom of the fraction. So that's why I've written it as 1 over u. So the integral of 1 over u is always the natural log of the absolute value. And of course I did it right here and then resubstituted the u back in. So there would be my final answer for that one. And then finally, last but not least, you have two expressions. You have a 6x plus 7 and you have a 6x squared plus 14x. So choose your higher power of x for your u. So my u will be the 6x squared plus 14x. When I derive that, I get a 12x plus 14, which does not match what I need. But what I notice is if I factor this 2 out, then I'm left with the 6x plus 7 and the dx that I'm going to need to substitute up there. So get rid of the 2 by dividing it, and when you substitute, you'll be bringing in a du over 2. Du over 2 is the same as saying 1/2 times du, so I pull the 1/2 to the front of the integral, put the du here. In the original problem, notice my u is in the bottom of the fraction raised to the 5th power. So that's 1 over u to the 5th. I rewrote it as u to the -5 just to make it easier to integrate. Add 1 to the power and you get a new power of -4 divided by that new power of -4, and then I simplify. If you're dividing by -4, it's the same as multiplying by 1 over -4. And when you multiply 1/2 times 1 over -4, you end up getting a -1/8. And then resubstitute your u back in, add your plus c, and you are finished.